Hello, good evening. Welcome to the presentation. Today we are explaining about strengthening cybersecurity for energy grids. And our team members are Rahul Soma, Anis SMD, myself Jitendra, and Kumari Koshuru. And today we're going to explain about the strengthening cybersecurity for energy grids and risk analysis and mitigation. So this discussion will explore the critical risk to energy grids and the strategies to mitigate them effectively, emphasize the importance of cybersecurity for energy grids, which are vital to maintaining uninterrupted services. Coming to the introduction, energy grids are increasingly targeted by cyber threats, which can lead to significant consequences such as service disruptions, data breaches, and operational ineffectiveness. This presentation categorized risks into specific areas like network security, tool incompatibility, endpoint risks and more, providing tolerated mitigation strategies for each. And coming on to the next one, technology risks. It was categorized into different parts. One is network security, tool incompatibility, employee resistance, implementation delays, supply chain issues, and global events. So coming to the first one, the network security, this has high probability of occurrence with potential impacts, including service disruptions and breaches. So penetration testing and implementing a robust multi-layer defense can be useful for mitigating these network security threats. And coming to the next one, which is tool incompatibility. So this has a medium probability risk that can cause operational failures due to poor integrations. So we can include compatibility testing and middleware solutions to mitigate this tool incompatibility. And coming to the next one, which is endpoint risk, it has high probability risk where unpatched devices serve as entry points for attackers. So to address this, use endpoint security solutions and real-time monitoring. And the next one is the employee resistance. This has a medium probability risk leading to implementation delays. So we can changing in management workshops can help addressing resistance effectively. And coming on to the next slide, which is human factor challenges in cybersecurity. So we have different categories in this as well, which is employee resistance and skill gaps. So coming to the employee resistance, the challenges is resistance to adopting new security protocols or technologies can delay implementation, and this impacts causing delays in rolling out critical updates and security measures. So we can conduct change management workshop to educate and engage employees about the importance of cybersecurity measures. And the next one is skill gaps. So the challenges in skill gaps is a lack of expertise among staff in advanced cybersecurity practices. This can impact to inadequate implementation of security protocol, increasing the risk of breaches. And we can mitigate by providing specialized training for existing employees, hiring cybersecurity experts to fill skill gaps. And coming on to the next slide, the process vulnerabilities in energy grids. This was categorized into different parts like tool incompatibility, implementation delays, supply chain issues, and global events as well, same as the before ones. So in this, the challenges for the tool incompatibility is poor integration between different tools and systems used in the energy grids. So this can impact to operation failure, making it easier for attackers to exploit inconsistency. So we can mitigate this by conducting compatibility testing to ensure tools and software work seamlessly, and also implementing robust integration plans with middleware solutions can also work or help us in overcoming these attacks. And the next one is implementation delays. The challenges in delays is delays in adopting or updating cybersecurity measures. So impacts or leaves an open vulnerabilities that attackers can exploit before defenses are fully implemented. So we can overcome this by utilizing agile project management to streamline processes and task risks in real time. And the next one is supply chain issues. The challenges in supply chain issues are resource shortage, or dependencies on unreliable vendors. So we can overcome. So what's the main impact regarding this one is creates potential gaps in system defenses or delays in maintenance and upgrades. So we can overcome this by effective vendor management to access suppliers' reliability or maintain resource backup to minimize disruptions. Coming on to the next slide, which is external threats to energy grid security. This was segregated into two different parts. One is the supply chain disruptions, the other one is unforeseen global events. So the first one, disruption, supply chain vulnerabilities. The threat in this one is dependency on third-party vendors and external supplies, intruders risks if these entries are compromised. And what's the impact in this one is cyber attacks targeting vendors on their supply chains can cascade into energy grids. We can overcome this by strengthening vendor management practices to evaluate and mitigate third party risks, and also keeping backup resources to ensure community if primary suppliers are affected. And the next one is global events. The main threat in global events is unpredictable events such as natural disasters, pandemics, or geo-optimal conflicts disrupt resource availability and operations. And this impact leads to operational failures or reduced reliance against cyber attacks. We can overcome this by developing contingency plans to manage disruptions effectively, or by incorporating flexible solutions that adapt to rapidly changing conditions. And coming on to the next slide, which is crafting a resilient mitigation plan. This was categorized into different parts like security, network security, tool incompatibility, endpoint risk, employee resistance, and skill gaps and implementation delays and supply chain issues and global events. So the general mitigation framework, the plan integrates a proactive approach. One is risk identification, the other one is mitigation design, and followed by implementation, and then after continuous monitoring. In risk identification is nothing but assessing potential vulnerabilities, and mitigation design is nothing but tailoring strategies specific to risk categories, and implementation is nothing but using agile and adaptive methodologies for execution, and continuous monitoring is nothing but ensuring real-time detection and response to emerging threats. So by employing this mitigation plan, energy grids can significantly reduce their exposure to cybersecurity threats and improve operational resilience. And coming on to the next slide, risk summary and prioritization. So it get prioritized in different ways like high probability, medium probability, and low probability, which is nothing but high impact, medium impact, and low impact. Coming to the high probability, there are which comes under the high probability category is network security and skill gaps, because the service disruptions and data breaches are the high priority because they were in the network security category. And and under the network security there are also endpoint risk which impacts system which helps the system compromise due to unpatched devices. And coming to the skill gaps, the main reason for skill gaps to be a high priority is the poor implementation of security measures. And coming to the probability, there are two different ones, which is tool incompatibility and employee resistance. The reason why the tool incompatibility came under the medium probability is because of its operational failures due to poor integration. And we also explained it in the previous slides that we can overcome this by compatibility testing and middleware solutions. And the reason why the employee resistance came under the medium probability is it's because of its delays in implementing security measures. And the low probability, there are two different ones in the low probability, which is supply chain issues and global events. So the reason why the supply chain issues is in the low probability because has a low probability is because of the resource shortage. Only it has the shortage or dependency on unreliable vendors. And the global events is because of resource disruptions from natural disaster or geothermal events, which cannot cause frequently. So that is the reason why these two comes under the low probability impact. And I would like to conclude this by by I would like to conclude this by addressing the critical importance of strengthening cybersecurity in energy grids by addressing a range of vulnerabilities. Energy grids face threats such as network breaches, unpatched endpoint vulnerabilities, and disruptions from global events, all of which can lead to service disruptions, operational failures, and resource shortage. A proactive mitigation plan is essential, combining technical solutions like penetration testing, endpoint security, and real-time monitoring with human-centric measures such as training, change management workshops, and high cybersecurity experts. So process improvements, including agile project management, compatibility testing, and robust vendor management. So further enhance system reliance as well also needed for improvement of the threats. So prioritizing risk based on their impact and likelihood and livelihood ensures efficient resource allocation. Thank you and have a good day.